Hi, 6th graders. We're jumping back into notes today. And remember, we've been in the unit where we've been adding and subtracting integers. So if you flip back a couple of pages, if you'll remember, we have now added integers, added negative and positive numbers together. We've also subtracted integers. We subtracted negative and positive numbers from each other, and those each had specific rules. And so today's notes are going to be the last part of this unit, which is multiplying and dividing integers. And so that's the title that we're going to write down. And we're doing these together because actually multiplication and division has the same rules. So the rules for multiplying and dividing are going to be the same. And so there's actually a way for us to help remember these rules. And so if you will draw a triangle, this triangle only works for multiply and divide, so I like to put an M and a D in the middle of it. And if you think about a mountain, the top is going to be our positive, that's the peak, and then at the bottom we're going to put negatives because, well, the bottom is negative. And so I'm going to split my page down the middle here in order to show some examples on each side. So if you'll think back to, let's do multiplication first. And we'll talk about how this triangle helps us remember these rules. If you'll think about what multiplication even means. So think back to maybe when you were in 2nd or 3rd grade learning your multiplication tables. You learned that 2 times 3 meant groups of. Right? So 2 times 3 would have been 2 groups of 3. And 2 times 3, of course, is 6 because 2 groups of 3 and then 3 more would make 6. Now, what's going to happen if we put a negative in front of there? Well, when we read this time, we're going to look at the positive number and we're going to say that's the group of how many. So in this case, putting a negative in front of this 2 is going to mean 3 groups of -2. 3 groups of -2. So the positive number is going to indicate the groups now, and -2 is going to indicate what's in each group. So if I think about what 3 groups of -2 looks like, well, there's a group of -2, there's a group of -2, and there's a group of -2. What would be the answer to -2 times 3? Or again, 3 groups of -2. Well, we just count them all, and there's 1, 2, 3, 4, 5, 6. So the answer to -2 times 3 is going to be -6. Now we can also look at this on a number line, and you may see some illustrations of some number lines as you're doing these problems. If we think about 3 groups of -2, what we could think about on the number line is hopping to -2 and then doing that again and again. So doing going -2 3 times. So 1 hop of -2, another hop of -2 would land me at -4, and then a 3rd hop would land me down here at -6. And so again, the answer to -2 times 3 is going to equal -6. I'm just going to put that up here. So the answer to this problem would be -6. And so that helps us understand that, well, when you multiply a negative times a positive number, your answer is going to be negative. So let's do that with just a different problem. Let's do 3 times -9. So this would be 3 groups of -9. Well, what is 3 times 9? What would 3 groups of 9 look like? Well, 3 times 9 is 27, but since they're groups of -9, the answer is just going to be negative. So actually, if you know your multiplication tables, multiplying integers is not that bad. You're still just doing regular multiplication, 3 times 9. It's just if one of the numbers happens to be negative, your answer is going to be negative. Now, that's the same as if the -3 had been the negative number, and if the 9 had been positive. So -3 times 9, this is now representing 9 groups of -3. Well, 9 times 3 or 3 times 9 still gives you 27. You still just multiply the numbers together, and one of the numbers is negative, so 9 groups of -3 would still end up with -27. Now, that's going to change if both of them are negative. So let's do -3 times -9. Now here we almost have to think about the opposite of an opposite, because if you have a negative, but then you have another negative, you're talking about negative groups now, which just indicates that we go back to positives. So you're still going to do 3 times 9, which is 27, But since they're both negative, they almost cancel each other out. So a negative times a negative is actually going to give you the positive 27 because it's going to be the opposite answer of these. One negative, negative answer. Two negatives, it's going to be positive. And of course, the only other option would be to have two positive numbers. So let's just go ahead and write that down. Of course, you've been doing this since you were in 3rd grade. So 3 times 9 is still positive 27. All right. And so the rule that we can sort of generate from this is that if we have the same sign, so if you're multiplying two numbers and they have the same sign, which is here, here, two negatives or two positives, the answer is going to be a positive number and you're just going to multiply like normal. So if you have the same, I'm going to write this here, same sign, and we're going to go, I haven't forgot about that triangle up there. We're going back to that. So if you have a positive times a positive, or if you have a negative times a negative, then the answer is going to equal positive. Same sign. Two negatives, two positives make a positive. However, if they're different signs, which is a positive times a negative or a negative times a positive, the answer here is going to equal negative. So here, and you put a big cloud around that because that's the big, those are the big rules for this section. Same sign, positive answer. Different signs, negative answer. All right. Also, let's not forget, and let's just talk about this very quickly, let's not forget that a dot is the only way of writing multiplication. Some of these problems that you're going to do in this unit use the x, of course, so 3 times negative 9. An x still indicates multiplication. A dot indicates multiplication. You also might see numbers in parentheses right next to each other. So if you see 3 parenthesis and 9 parenthesis, having a lack of a sign in the middle here indicates multiplication. So you're still multiplying these numbers together. So that would be like this problem right here. Also, you may see one number out in front and then the second number in parentheses. That also indicates multiplication if there's no sign in between them. And I think that is all. So if you are working a multiplication problem, you might see it written with a dot, you might see it with an X, or with two numbers right next to each other in parentheses, or with the second number in parentheses. So just don't forget that. That all indicates multiplication. All right, let's look up here at the mountain or this triangle that helps us remember these rules. So now that we know what the rules are, if you can just sketch out this picture every time you're doing these, it will help because it will help you remember what should happen. Because a positive times a negative, what I can do is I can go up here and I can just cover up, I'm multiplying a positive times a negative, and then whatever is left over is going to be your sign. So a positive and a negative should be a negative. A negative times a positive should be a negative answer. Two negatives, if I cover them both up, I'm multiplying two negatives together, the answer is going to be positive. And then, of course, positive times positive, you should know. So that's how we use the triangle to help us remember these rules. So I told you before, division is exactly the same way. Exactly the same rules. Do you have V-I-S-O-N? Yeah. All right, so let's talk about division for a second. -4 divided by 2, just for an example. If we're looking at this as far as a model goes, if I have four negatives, and I want to cut them in half or cut them into groups of 2, well, that would be, here's a group and here's a group. I just divided them into 2 equal groups, and so my answer is what I have in each group. So there's 2 negatives end up here and 2 negatives end up here. So the answer to this division problem would be -2. On a number line, you may see division like this. If you are asked to split -4 in half, there's going to be a line from 0 out to -4, and it's just going to cut it in half. And so that, again, is -2. So the answer to the problem -4 divided by 2 is -2. And, of course, that lines up exactly with what we found over here. If you have one negative and one positive, your answer is going to be negative. So I'm going to do a few problems here. And we're going to use the same rules. We can use our triangle, or we can remember same sign, positive, different signs, negative. So you might see something like -50 divided by 5. Well, 50 divided by 5 in general is 10, but we have a negative and a positive number. So those are two different signs. We can also go up here and use our triangle. A negative divided by a positive is a negative number, so negative 10. Otherwise, the division works like normal. What if we see negative, nope, we already did negative. Let's do positive 50 divided by negative 5. Positive divided by negative. Again, we can use our triangle. So a positive, cover that up, divided by a negative is going to get a negative answer again. And they're different signs, so we know it's going to be negative. So again, this answer is going to be negative 10. If you're dividing two negatives, so if it's negative 50 divided by negative 5, those are the same sign. Answer is going to be positive, or you could just say negative, a negative gives you a positive. And so that's going to be positive 10. And of course, positive 50 divided by positive 5 is also going to be positive 10. So if you can remember these rules, then you can multiply and divide integers. One last thing, just like multiplication, there are different ways of writing division. So of course you might see the division sign. You might also see some of these problems written as negative 50 over 5. You might see it written as a fraction, and just remember that fractions also mean division. That's probably the only way. You might see it written with a slash like this as well. But that's usually the only other way of writing division. So there are your rules. Use these rules as you practice multiplying and dividing integers.